Okie dokie, so today we're talking about cellular respiration and the numbers behind it. So it's been kind of a long week, but let's just pound this out and get it over with. So first I want to start with the glycolysis reaction. Remember, we put in one glucose, so we're going to be following this reaction through with one glucose and the oxygens, okay? So our one glucose through glycolysis is going to yield 2 NADPH, and it yields a net of 2 ATP. Then in the link reactions, remember, we're going to get technically 1 NADPH per pyruvate, but the glycolysis makes 2 pyruvates, so we're going to get 2 NADPHs and 2 CO2s. We don't get any ATP from this. Then into the Krebs cycle. This is where the moneymaker is, right? And I'm just going to do totals here. So we get total of 6 NADPH, and then we get 2 FADH2s. Going to get a total of 4 carbon dioxides out of it. So note here we have 6 carbon dioxides, which is how many goes into our reaction, so we're good on carbon dioxides. Cool. Now we need, and we get 2 ATP, so 2 ATP. Awesome. Now we go into oxidative phosphorylation, and basically the thing to keep in mind is here is that we get a total of, I have a little sticky note here with my stuff on it, we get a total of 3 ATP from 1 NADPH, and we get 2 ATP from one thing of FADH2. Okay, so now let's have a total. So if we have 8, I'm going to have to pull up my calculator. I'll be fine. So we have 8, 1, 2, 3, 4, plus 6. We have 10 NADPHs, right? NADPH. So we're going to multiply that by 3, because each one makes 3 ATPs. That's going to get us 30 ATP from our NADPHs that we have. Then since we have 2 FADHs, FADH2s, we're going to multiply that by 2, and so we get a total of 4 ATP. So we add those together, and we get 34 ATP total from oxidative phosphorylation. So, and from this we're kicking out, the NAD plus and the FADs and the hydrogens, ions, and all that. But counting ATPs here, get 34 ATP plus the 2 ATPs from Krebs, and then plus 2 ATP from the glycolysis. That gives us a sum total of 38 ATP, and that's our lot of energy that we're getting. So it takes one glucose, CH12O6, that's our one glucose we started with up here. We're going to add some oxygen atoms, O2s, because these hydrogen atoms bond in oxidative phosphorylation to the oxygens. And that's going to give us some 6 CO2s. Because we put 6 carbons in, we're going to get 6 carbons out. And then some H2O as well comes out of that. So if we had, 6 of these, we're going to get 12 H2Os out. Something like that. And that's plus 38 ATP. Now, is it always 30 ATP? No. It's not always 30 ATP. That's in perfect conditions. But in general, perfect conditions, 30 ATP. That's kind of where the number comes from. And I hope that was helpful.